welcome to this session on anti-differentiation integration problems. These are useful in AP Calculus. So we will be illustrating a few problems today. Let's start with problem 1. Evaluate integral sine 2x by 1 plus sine squared x dx. So we make a substitution, put 1 plus sine squared x as t and differentiate this with respect to x and right hand side with respect to t. So you get 2 sin x cos x dx is dt. But 2 sin x cos x is sin 2x, so you get sin 2x dx is dt. Substitute in this integral, so you get integral dt. Sin 2x dx becomes dt, so dt by 1 plus sine squared x is t. Integral dt by t is log mod t plus c. And what do we do now? We substitute for t. T is 1 plus sine squared x. So it becomes log mod 1 plus sine squared x plus c. Let's go to the next question. Evaluate integral dy by y root 1 plus log y. Now here we make a substitution. Put root 1 plus log y as t. And when you square it, what do you get? 1 plus log y is t squared. Differentiate left hand side with respect to y, right hand side with respect to t. So you get 1 by y dy is 2t dt. And what do you get when you substitute in I? You get integral dy by y becomes 2t dt and root 1 plus log y becomes t. So the t gets cancelled and what do you get? 2 integral dt, which is 2t plus c. And now you substitute for t. What is t? T is root 1 plus log y. So your answer is 2 root 1 plus log y plus c. Now the method of partial fractions is used when degree of numerator is less than degree of denominator. So let's see one problem on this. Evaluate integral x squared minus x plus 4 by x cubed minus 3x squared plus 2x dx. So we will factorize the denominator, take out the x and it becomes x into x squared minus 3x plus 2. And when you factorize x squared minus 3x plus 2, what do you get? X minus 1 into x minus 2. So your factors are x into x minus 1 into x minus 2. Now you will write this term x squared minus x plus 4 by x into x minus 1 into x minus 2 as a by x plus b by x minus 1 plus c by x minus 2. We have split it into fractions. And what happens when you take the LCM and cancel the denominators? You get x squared minus x plus 4 is a x into x minus 1 into x minus 2 plus b x into x minus 2 plus c x into x minus 1. Now in equation 1, if I put x equal to 0, I get 4 equal to a into minus 1 into minus 2. So a is 2. What will you put to get b? Put x equal to 1 in equation 1. So I get 1 minus 1 plus 4 will be b into minus 1. A and c disappear and you get b as minus 4. Again, put x equal to 2 in this equation 1 and what do you get? 4 minus 2 plus 4 will be c into 2 into 2 minus 1, which is 2. So c equal to 3. So your partial fractions becomes 2 by x minus 4 by x minus 1 plus 3 by x minus 2. And now you integrate it. So what is integral 1 by x? You get log mod x minus 4, log mod x minus 1. And what is integral 1 by x minus 2? Log mod x minus 2 plus c. Now substitute. And before that, log mod x is log x squared because log a raised to m is log m log a. This becomes log x minus 1 raised to 4. And what does the third term become? Log x minus 2 the whole cubed plus c. And log a minus log b is log a by b. So it becomes x squared into x minus 2 the whole cubed by x minus 1 raised to 4. Log a plus log b is log ab. So this is your I, your final answer. Now integration by parts states that integral fx gx is fx integral gx minus integral of f dash x into integral gx dx. So basically integral uv is u integral v minus integral of derivative of u into integral v. I stands for inverse trigonometric, L is logarithmic, A is algebraic, T is trigonometric and E is exponential. So this is the order that we use. So with an exception of integral e raised to ax sin bx dx or integral e raised to ax cos bx dx, we don't use this rule for order here. So let's start with a simple problem. Evaluate integral x cos x dx. So the order is right, at. So it becomes x integral cos x dx minus integral of derivative of x is 1. What is integral of cos x? Sin x dx. So you get x sin x minus integral of sin x is minus. So you get plus cos x plus c. Let's go to the next question. Evaluate integral e raised to x cos x dx. So as I mentioned, this is an exception and we will not follow the order here. So this becomes e raised to x integral cos x dx minus integral of what is derivative of e raised to x? E raised to x integral cos x is sin x dx. So the first term is e raised to x sin x. Again you apply integration by parts here and you don't follow the order. So it becomes minus e raised to x integral sin x dx minus integral of e raised to x. What is integral of sin x? It's minus cos x. So you get plus integral e raised to x cos x dx. That is e raised to x sin x plus e raised to x cos x minus integral e raised to x cos x dx, which is your I. So take the two i's together. You get 2i is e raised to x sin x plus e raised to x cos x plus c. So I becomes half e raised to x sin x plus e raised to x cos x, and we are writing c as c because c by 2 is a constant, c is also a constant. So thank you for this class. We have learned a few problems on partial fractions and integration by parts and the substitution method. Thank you.